Tuition Mobile, quality e-learning experience on the go.
Hello and welcome back to our class. In this section, we'll be discussing on statistics titled the use of frequencies to construct histograms. The use of frequencies says to construct histograms. Okay, histograms. All right, and so in this particular lesson, we'll be defining some little major aspects of statistics. We'll start by using examples. Okay, start by using examples. Assuming you are given the table of value, for example, 1. If we are given the table below, okay, and we are asked to construct a histogram, we'll go step by step. Okay, I want to draw my table, the table with various columns. Okay, and the columns denote columns here, values are located. All right, this is where they assume numbers 1, 2, 3, 4, 5 and 6. I have 6 data points here, and then I extend my table. Okay, and the first column there, I have the class limits. Okay, and then on the other column I have the class boundaries. And then the next I have the class mark. And then I have the tallies. Now we've done this in your statistics 1 before. We've talked about the tallies. Then after the tallies I have the frequencies. Alright, my table ends here, I assume. Okay, and then another column. Fine. And then the last column is a column of frequencies. Okay. Alright, these are the steps you consider when you want to construct your histograms. Alright. And so for the first column, we have something called the class limit. And so we have to define what the class limit is. Okay, the class limit consists of 2 values. One we call the upper class limit, and the second value we call the lower class limits. Okay, class limits are used to represent interval scaled class limits. They are used to represent interval scaled frequencies. Used to represent interval scaled frequencies. Remember that data can be grouped into point data and interval data. We did that in your statistics 1. All right, and so for this interval, it has 2 sides. The 2 sides of an interval are the 2 sides of a class limit consist of the upper class limit and the lower class limit. Okay, and so for the example we have above, we have 9 to 10. Okay, we've grouped data in this form before, so you can refer back to that level, to that lesson. 11 to 12, 13 to 14. Okay, then 15 to 16, 17 to 18, 19 to 20. All right, and so we will discuss on how class boundaries are formed. we're going to find out how class boundaries are formed and look at these class limits. Okay, before we go into class boundary, I want us to talk about class width. The class width okay, the class width is defined as the number of units in a class, okay, just like we have in the first class. We have 9 to 10, and these have to be to include numbers ranging between 9 and 10. So the class width there is equal to 2, because you have 2 points within the numbers there. Okay, so the class width for the first class includes numbers 9 and 10, and so the class width is equal to 2. The class width is defined for all the class limits. The class width remains the same for all the data points for all the class limits. All right, and so I want us to define the class boundaries. Okay, you have to define the class boundaries. All right, and I'll say that for the example we have above, the upper class boundaries are as follows. Okay, go back and look at them. The upper class boundaries are the boundaries on the right hand side. They are 10, 12, 14, 16, 18, 20. So 10, 12, 14, 16, 18, and 20. You already have them on the table, so I'm just trying to create distinction. Why the lower class boundaries? The lower class boundaries are as follows. Where you have 9, you have 11, you have 13, 15, 17, and 19. And 19, take 2. And we go back and we define the boundaries, the class boundaries. Okay, the class boundary is defined as like I said, the class boundary is obtained in the following way. All right, look at what we do to obtain a class boundary. The lower class limits of the first class, the lower class limit of the second class, okay. All right, is added to the upper class limit, okay, class limit for the first class. All right, and their sum divided by 2, and their sum is divided by 2. Okay, when we add the lower class limit of the second class, okay, to the lower class, to the upper class limit for the first class, and then the sum is divided by 2, it gives us the lower class boundaries, the class boundaries for each class. All right, we'll illustrate what we just said. For the classes, we have 9 to 10, we have 11 to 12, we have 13 to 14, 15 to 16, 17 to 18, and the rest. Okay, let's try to find the lower class, the class boundaries for 9 to 10. The instruction there says that we should add the class limit of the second class, the lower class limit of the second class, okay, and it's added to the upper class limit of the first class. All right, the lower class limit of the second class for class 9, okay, is given as the lower class limit of the second class is given as 12. Sorry, is 11, because we have a lower class limit here. This is the second class, is 11, and then the upper class limit for the first class is 10. All right, and so we have to add 10 and 11, okay, and then we divide by 2. This gives us 21 divided by 2, which will give us 10.5. So we have this as 9 to 10.5, and then this as 10.52. Okay, let's find out what stays here. The same thing, 13 plus 12 all over 2, which gives us 25 over 2, and this gives us 12.5. So here is 12.5, and then here is 12.52. all right, and then what is the class limit boundaries for this class? We have 15 plus 16 divided by 2, and we have 31, right? Yeah, 31 over 2. Okay, sorry, is that 15 plus 14? Sorry, that's 29 over 2 rather. So giving us when we divide into 2's, we have 14.5, right? And so we have 14.5 at this point, 12.5 to 14.5 at this point, 14.5, 14.5. okay, now we go and do for 14 and 11, and so we have 11 plus 14, okay, divided by 2 to give you 25 over 2. This gives us 22.5, right? Fine. So if there's an omission here, so we have 15 plus 14, okay, 15 plus 14, okay, this is okay, 14 to 15 is omitted at this point. 14 to 15 is omitted at this, so we can do I think there's something wrong with this table, but then I believe you've gotten the idea we're talking about. So the class boundaries here will be from as we had 10.05, okay, have 10.05 to 10.05, okay, and it continues in that, right? And then we have 10.05 here too, right? 10.50 rather, 10.5, okay, that was all the way up 10.52 at this point, 10.5, and then the next is adding these two values. We have the lower class for the second class, then the upper class for and we have 12 plus 13 divided by 2 give us 12.5, okay, and then here too 12.5 to 15 plus this plus 14 gives us 29, yes, and then we have 14.5 at this point, and then 14.5 here too. Then 16 plus 17 will give us 6 plus 7 gives us 13, and divided by 2 we have 16.5, okay, and it continues that way, 16.5 for the first class here, and then 18 plus 19 gives us I think that should be 27, and then when we divide by 2 we have 27. Is it 27? Yes, we have 18.5, okay, that is 18.5 and 18.5 at this point too. So if we continue in that manner, all you just need to do is to notice that the upper classes change by added 0.5, okay, 0.5 is included to the upper class, okay, and so you have 20.5 to the upper class, and the lower classes are reduced by 0.5 according to this analogy, and so we can write this as 8.5 when we remove 0.5 from this. And so this is how you determine your class boundaries, okay. Now we're going to finding the class mark, determining the class mark, all right. And so we say that if the lower class limit is added to the upper class limit for any of the class and their sums divided by 2, that will give the class mark, okay. And so let's talk about the class mark here, okay. The class mark is the average, okay. if the lower class limits is added to the upper class limit, is added to the upper class limits, okay, and is divided by 2, okay, by 2, we have what we call the class mark. And so we are saying that class mark is equal to lower class limit, okay, plus upper class limit, okay, and then divide by 2. All right, so we take the first example there. Lower class limits divided by 2, we have 9 to 10, 9 to 10, 11 to 12. Okay, let's try 9 to 10, 11 to 12, 13 to 14, 15 to 16, 17 to 18, and others. Let's try summing this. If you sum them, 9 plus 10 gives you 19, 11 plus 12 gives you 23, and then 13 plus 14 gives 27, while 15 plus 16 gives 31. Yes, and then 17 plus 18 gives 30 is 35, right? And so what we have to do now is to determine the class mark is, let this column be for the class mark, okay, for all of them. And then the class mark is determined by dividing by 2 the sum of both the upper class limit and the lower class limit, right? And then 19 divided by 2 gives you 9.5. 23 divided by 2 will give us 11.5. 27 divided by 2 will give 13.5. Okay, and then 31 by 2 also gives 15.5. 35 by 2 gives 17.5. 17.5. So we go back to our table and then update this as the values 17.5, and then we have 9, 11, 13, 15. We have 9.5, 11.5, 13.5, 15.5. The same thing here. Let's find for the 6th class. We have 19 plus 20 divided by 2, so we have 19.5. 19.5. All right, so how do we go about the tallies? All right, the tallies here are represented in this manner. All we do is to go back to the table of values where we had the frequencies for these numbers, the numbers that range from, for this case we'll take a typical example so that we'll form a complete table and then apply all we have said here. All right, let's take for example the table of observation of production, daily production, for example. The table below, example 1, the table below, okay, shows daily production of bread in a given company. Okay, we don't know the name of the company, we're just making examples so that you can see how we apply all we've said. Okay, and so we have the data has given us 9, 13, 17, 15, and then 17 for this, and then we have data like 11, 13, 18, 13, 16, and then here we have 10, 13, 17, 14, 15. Okay, and so this side we have 10, we have 13, 17, 15, and 15. Okay, we have data of this form, and the contents the data. I wouldn't like to waste our time anymore, and so we'll be using a class suite, using a class suite of 1. Okay, determine the mean and the standard deviation, as well as the variance, and variance for the data above. Okay, so all we have to do now is to classify them according to intervals using a class weight of 1. Okay, a class weight of 1 means only one class can be skipped: 9 to 10, 10 to 11, 11 to 12, 13 to 14, and so on. And so the highest number we have here is the biggest number here is 19. Okay, and so we apply our class suite. And then we have on this page we have the following tables. And so make a table of the form above, and then we begin to group into class intervals. The class intervals we have are 9 to 10, 11 to 12, 13 to 14, 15 to 16, 17 to 18, 19 to 20. Okay, we're having 6 classics because of the numbers there. The highest number there is 19, and so, and grouping them in using a class weight of 1, we have 9 to 10, 11 to 12. Okay, and then if you're told to group using a class weight of 2, okay, you have 9 to 11, 12 to 14, and it continues in that format. All right, so the class boundaries, which we said they are obtained by adding the lower class boundary for the second class to the upper class boundary of the first class and dividing by 2. We've done this before, and so we obtained 8.5 to 10.5 here, 10.5 to 12.5 here, and then 12.5 to 14.5. all right, and then we have 14.5 to 16.5, and then 16.5 through 18.5, and then 18.5 through 19.5. okay, and then we've obtained the class mark. The class mark, we said, is when you add the lower class interval and the upper class interval and you divide by 2. okay, and then we've obtained the class mark on this column. okay, where we have the class mark as 9, 11, 13, 15, and the following number. all right, the system is, so we check the frequencies. We go back to our table, and then we check for numbers grouped under 9 to 10. We have 1, 2, 3, 4, 5. okay, 5 numbers fall under 9 to 10, so we write 5. Go back again and check for 11 to 12. We have 1, 2, 3. okay, 11 to 12. That's all we have for 11 to 12, 3. And so under 13 to 14, we have 1, 2, 3, 4, 5, 6, and 7, 8, and 9, and 10, and 11. all right, we don't have any other 13 to 14, so under 13 to 14 we have 11 digits there. fall under this group. Then 15 to 16, we have 1, 2, 3, 4, 5, 6, okay, 7, 8, 9, and 10, and 11, and 12, alright, and 13, and 14, alright, and 15. That's 15 to 16. Do we see any number 15 to 16 again? No, so we have 14. Okay, let me go back and count to make sure they are complete. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. Right, there should be 15. This is 15. Okay, I can see one other number belonging to 13 not being cancelled, and 13, 12 to 13 belongs to that group. 13 to 14, and 13 to 14 we have 1, 2, 3, 4, 5, okay, 6, 7, 8, 9, 10, 11, and this making it 12. Okay, 13 to 14 making it 12. Okay, not 11 but 12 is the frequency. Alright, we'll go back and carefully check for 17. Right, we check for 17 to 18. Not 17 to 18, we'll have 1, 2, 3, 4, okay, then 5, and then 6, and 7, and 8, and 9, and 10, and 11, and 12. Okay, we have 17 to 18, 12 digits there. Alright, and then for 19 to 20 we'll have 1 and 2. Do you have any number uncycled or marked? Okay, let's check back. We have a number marked, and it's 11. 11 belongs to which group? 11 to 12. Okay, that means this should be 4, and then we'll mark 11. 11 is marked with this star. Alright, and so we change this from 3 to 4. Alright, so when you do, alright, so from the frequency we have 5, we have 4, and then we try to add them to get the total frequency. You have 5 plus 4 plus 12 plus 15 plus 12 again, then plus 2. It gives you that the total frequency there is equal to 50. So summation F is equal to 50. Alright, and for the tallies, they are represented this way. The number of 5, okay, rounded up at a count of 5, okay, and then 2. They all rounded up at a count of 5. 1, 2, 3, 4, and then 1, 2, 3, 4, 5. Rather, so it makes up 15. Alright, so 1, 2, 3, 4, and 5. And so this is 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, and 1, 2. That's 12, and this is 2. Alright. Okay, so on this column we try to find fx, and fx means multiplying the class mark by each of their frequency, and the class mark for the first class is 9.5 times the frequency of 5. We have 47.5, and then the second class there we have 11.5 times the frequency of 4, and then we have 46. We have 46. Alright, and then the next class we have 13.5 times the frequency of 12, and then we have 162. Okay, and then 15 times 15.5. Okay, we have 232.5. 232.5, and then they have 12 times the frequency of 17.5. we have 210, and then we have 2 times the frequency of 19.5, the class mark 19.5, and then we'll have 39. Alright, so we can as well find summation f and x to be equal to adding all the numbers there, 47.5 plus 46 plus 162 plus 232.5 plus 210 plus 39, okay, which gives us 737. Alright, we have to say this before we continue, that remember that the mean for ungrouped data is given as summation of x minus x bar. Sorry, this is variance instead, I think. Alright, so I mean the mean of ungrouped data, let me quickly, the ungrouped data is given as summation of xi over n. Alright, but this is for ungrouped data. Okay, for the group data is given as x bar equal to summation of f and x all over summation of f. Okay, where summation fx means each of the data point multiplied by number of frequencies. Okay, and summation f means the total number of frequency, and the total number of frequency is the same thing as the total number of occurrence or the total number of outcomes, just like you see. As you can see here, you have 1 2 3 4 5. If you keep counting, it will give you that the data points n is equal to 50. All right, and so this is for grouped data. And so the mean x bar for the group data we've illustrated for is equal to summation fx, where summation fx from the table there is equal to 737, and summation f is equal to 50. That's summation fx, and this is summation f, okay, which is equal to 50. All right, and so we can say this is 737 divided by 50 to get the mean, and so we have the mean as to be equal to 14.74. So therefore we can say x bar is equal to 14.74. All right, so we still talk about other aspects of the grouped data, because we can find the variance too. We can as well find the standard deviation. Okay, but we want to say this especially that ungrouped data are used for plotting of the frequency distribution, the histogram. Okay, you can use the ungrouped data to plot the histogram. So before we go into calculating the variance, I would like us to use the table we have here to construct a histogram for these frequencies and for these data given here. All right, and so we go ahead to the next page, and then we introduce the term histogram. What is a histogram? Okay, I would like to say that a histogram is made up of bars. Okay, I wouldn't like to go into definitions, but with the properties you will understand what a histogram looks like. Okay, properties. Okay, number one, made of bars, just like you have the bar chart. Okay, but the bars, especially, but its bars are not spaced. They are not spaced just like you have in your bar charts. Okay, the bars has no gaps between them. Good. And then they have rectangles just like you have in your bar chart, but the rectangles correspond to the frequencies, to the class frequencies. Okay, made of rectangles that correspond to the class frequencies, corresponds to the class frequencies. Okay, and they are read along the vertical axis. Along the vertical axis. Okay, and so the class boundaries of the data we want to present are marked on the horizontal axis. Okay, at the point where the lines for the bars of the rectangles are drawn. Okay, alternatively, if you don't want to use this method, you can as well use the midpoints of the bases of the rectangles. Okay, you can use the midpoints of the bases of the rectangles. When we want to draw these diagrams, you will understand better. I'll still make more explanations on this, but right now let's go into fixing the bar, the histogram rather. Let's go and fit in the histogram. Can you enter this place? Alright, let me try to make it brief and simple. Okay, I'll fit my histogram on this page. Right, just like any other graph, it has an x-axis, the vertical and the horizontal axis. Alright, and the frequencies are plotted on the y-axis. Okay, while the class boundaries are plotted on the x-axis. Okay, I will show you my method for picking the class boundaries that are to be represented on the x-axis. Alright, my origin is 0, but since I have discrete points here, they are represented with zigzag lines. Okay, then I go back to my table of frequencies. The highest frequency there is 15, so I'll have to make numberings such that I'll have to choose a scale such that 15 or even 20 could be the highest number. And if I go by scales of 2, okay, 2 centimeter to 1 unit, let me see what happens. Will it enter? Have 2, 4, 6 and 8, it will enter. So I better go with a scale of 10, 1 centimeter to 10 units to 5 units, rather have 5, 10 and 15 and then 20. Okay, this is better. And so I have to give equal units to the portion, the horizontal axis where the class boundaries will lie. I have to give equal units to them, and so I will show you the class boundaries I'm going to choose so that we can carry out our computations. Alright, look at my method of choosing my class boundary. I'll move from this way and down. Okay, I'll move from this way and down. Alright, so if I move from 8.5, I have 10.5, 12.5, and then I have 14.5, 16.5, and then the cycle continues. Okay, that's the way I choose my class boundary, so that I have 8.5 here. Then I have which other one? I have 8, 10, 12, 14. Okay, 8, 10, 25, 12.5, and then 14.5, and then I have 16.5, 18.5 and 20.5, 16.5, 18.5, and then 20.5. Alright, it's not that difficult. All you have to do is to start from where the class boundary for each class started to locate the frequencies. And if the frequencies I have for the first class, the frequency is 5, right? And then I go to the first class. This is exactly the point where I have 5, and then I fit my bar. The first class is a class of 8.5 to 10.5, 8.5 to 10.5 with a frequency of 5. All right, with a frequency of 5, I'm trying to fit a good histogram at that point. Fine. And then from 10.5 to 12.5, I have a frequency of 4, a little bit lower than, a little bit below this other frequency, a little bit below this other frequency, shorting a difference of 1. All right, and so we have the frequency here. Okay, and then the next we have is frequency of 12, 15, 12. Okay, let me get that down to my memory. 12, 15, and 12. And so, and 12 is from 12.5 to 14.5, and then I'll trace it down up to 12. 12 should be at this point. With your graph, you don't need to make assumptions like me. I'm not using a graph, so I have to try my best to fit this with a freehand scale. Alright, and then for 15 should be at this point. You can see 15 is here. Alright, this is the point where I have 15. I trace the line down. Okay, and then 12 again. I have 12 at this point. Alright. Okay, and then the last number there is a frequency of 2. Okay, so a frequency of 2 will fall on this side. All right. Wow, and this gives us a frequency distribution, and in a frequency distribution, in the diagram, the bars with the greater length is known as a bar containing the modal class. Okay, in the frequency distribution, the bars with the greater length is said to contain the modal class. Okay, fine. That could be gotten using the frequency. The histogram is the frequency polygon. The frequency polygon is obtained by joining the midpoints of the bars. The frequency polygon. Okay, by marking out the midpoints of the bars, and joining its lines. Okay, so when we mark out the midpoints of the bar, we join the lines. Okay, well, let's go back to our bar. Assuming here it's the midpoint for this bar, then here it's the midpoint for this bar, here's the midpoint for this bar, and here's the midpoint for this bar, and here, and then here is the midpoint for this bar. So how do we join this line? We can join this line, this joins to this, and then this joins to this, and then this joins to this, and this joins to this, and then we join this to this. Okay, and then we join at the midpoint of this line to complete the frequency polygon. Join to the midpoint here. Okay, so the diagram we have here is called the frequency polygon. All right, frequency polygon. All right, so with this we've come to the end of this class, and in our next class we'll continue with finding the variance and standard deviations for the given data. Just keep in touch. Goodbye.